Hello everybody. We'll be further going through the numericals or problems related to moments. So we have just gone through the concept of moments. Hope you are clear with the concept of moments. See, when we find or when we calculate moment, the first and foremost thing which you are supposed to determine is, or which you are supposed to check, is whether the external force produces clockwise moment or anti-clockwise moment about a particular point. This you are supposed to determine, or this you are supposed to understand. So before you find the moment about a particular point. So to understand this, before we start solving the numericals, quickly let me just give you a small thumb rule to understand whether the given force produces clockwise or anti-clockwise moment about a particular point. For example, the force can be vertical, or line of action of force can be vertical, or line of action of force can be horizontal. Let me draw the line of action. So if the line of action of force is vertical, the force can move vertically upwards, let me write it as F1, and force also can move vertically downwards, let me write it as F2. So if the line of action is horizontal, force can move either horizontal to the right, let me write it as F1. Similarly, the same force can move horizontal to the left, let me write the same force as F2. These are the possibilities. Let us consider the first case where the force moves vertically upwards or downwards. Upwards or downwards. These are the only two chances. And let me consider a point A, which is in the left-hand side of the line of action. Left-hand side of the line of action. Let me consider one more point B, which is in the right-hand side of the line of action. 2 points. And let me consider these 2 points as the points of rotation, or points about which we need moment. Let us consider this force now, force which moves vertically upwards, and let us consider the point which lies in the left-hand side of the force. So if the force moves vertically upwards, and if the point about which we need moment lies in the left-hand side of the force, then the force should produce moment in this direction. Similarly, let me consider the same force which moves vertically upwards, and that the point about which we need moment lies in the right-hand side of the force. If the point lies in the right-hand side of the force, then the force should produce moment in this direction. Hope this is clear. Similarly, let me consider the vertical force which moves vertically downwards, and let me consider the same point which lies in the left-hand side, point A. So if the force moves vertically downwards, and if the point is in the left-hand side of the force, then the force should produce moment in this direction. Let me consider the same force. Which moves vertically downwards, and let the point be in the right-hand side, and then the force should produce moment in this direction. It is quite similar when we consider the horizontal line of action as well. In the case of horizontal force, the point about which we need moment may lie above the line of action, or it may lie below the line of action. Let us consider the force which moves horizontal to the right, and let the point about which we need moment be above the line of action. So if the point is above the line of action, if the force moves horizontal to the right, then the force should produce moment in this direction. Similarly, if the point is below the line of action, then the force should produce moment in the other direction, in this direction. Let me consider the F2 which moves horizontal to the left, and let the point about which we need moment to be above the line of action. If the point is above the line of action, then the force produces moment in this direction. Similarly, if the point is below the line of action, then the force should produce moment in the other direction. This is how you determine the direction of moment produced by all the forces. Hope this is clear. Hope this concept is clear. Let us start solving the problems. Let us start with the basic problems, and then solve some problems from the notes, and the other problems are to be solved on your own. If you have any doubts, you can ask me anytime. Yeah? Let us start solving the basic problem. Let me consider a body in this way. Let me mark this point as A, let this point be B, let this point be C, and let this point be D. Okay. Now, I have an external force of, say, 20 Newton magnitude which acts at A. This is a horizontal force of 20 Newton magnitude. horizontal force. Then let this distance be 2 meters, let this be 4 meters, this be 1 meter. Now, according as per this particular problem, we need a moment produced by this force of 20 Newton magnitude about A, B, C, and D. About A, B, C, and D. Now, before we particularly solve this problem, there are two cases. There are two cases where moment becomes zero. There are two cases where moment becomes zero. The first case is that when the force acts exactly on the point of rotation. For example, here, force acts on A, so moment about A will be zero. If the force acts exactly on the point of rotation, then the moment becomes zero. And the second case, if the line of when you draw the line of action of force, if the line of action of force passes through a particular point, when you draw the line of action, if the line of action passes through a particular point about which we need moment, then the moment will be zero about that. Got it? So these are the two cases where moment becomes zero. The first case is where when the force acts exactly on the point of rotation. For example, in this case, the force acts on A. So we need, according to the question, we need moment about A, B, C, and D. We need moment about A, B, C, and D produced by this particular force of 20 Newton magnitude. But 20 Newton magnitude force acts exactly on A. So moment about A will be zero. Moment about A will be zero. This is one of the cases. And in the second case, when you draw the line of action of force, here let me draw the line of action of force. This is the line of action of force. If this line of action lies, or if it passes through a particular point about which we need moment, then moment about that point will be zero. Moment about that point will be zero. So these are the two cases where moment becomes zero. Let us start solving the problem. So here, moment about A will be zero because force acts exactly on point A. Moment about B. So before you find the moment about B, check whether the force produces clockwise or anti-clockwise moment about the point B. Check whether the force produces clockwise or anti-clockwise moment about point B. So line of action is horizontal, force moves horizontal to the left, and point about which we need moment lies below the line of action. So force should produce moment in this direction. Hope this is clear. So it is anti-clockwise. Minus, put the bracket, write only the magnitude. The magnitude is 20, no direction, only magnitude. Into the perpendicular distance from the line of action of force to the point B. This is the line of action, this is point B. What's the perpendicular distance? It is 2. So the moment will be minus 40 Newton meter, or you can write it in this way, 40 Newton meter anti-clockwise. 40 Newton meter anti-clockwise. Hope this is clear. So we got moment about A, moment about B. Now let us go through moment about C. Again, check whether the given force produces clockwise or anti-clockwise moment about the point C. Again, the line of action is horizontal. And the force moves horizontal to the left. And the point about which we need moment lies below the line of action. So it produces moment in the same direction. So anti-clockwise again, minus 20 into what's the perpendicular distance from line of action to C? It is again 2. This minus sign is because of the direction of rotation of the body. Then the moment about D. Again, check whether the given force produces clockwise or anti-clockwise moment about the point. Again, the line of action is horizontal, force moves horizontal to the left, and the point about which we need moment lies below the line of action. So according to the rule, it should be anti-clockwise. Again, it is minus. The magnitude is 20 into, what's the perpendicular distance? This is the line of action, this is the point of rotation. So this should be the perpendicular distance, is it not? This should be the perpendicular distance. So 2 minus 1, or 1 meters will be the perpendicular distance. So it will be 20 Newton meter anti-clockwise, or minus 20 20 Newton meter anti-clockwise, or it will be minus 20 Newton meter. This is how you solve numericals. This is one of the problems. This is one of the problems. Let us solve 2 or 3 more problems in the same session. Now, second problem, problem number 2. Let me consider a rectangular plate in this way. Rectangular plate. And let me consider an inclined force of, say, 100 Newton magnitude. Say 100 Newton magnitude. And let the inclination be 30 degrees. Let the inclination be 30 degrees. Let this particular point be A, let this be B, let this be C, and let this be D. And let me write an intermediate point, let it be E. So we have 1, 2, 3, 4, and 5 points. We have 5 points altogether. Let this be 2 meters, and even this will be 2. This is the given question. This is the given question. And according to the given question, we need moment about the points A, B, C, D, and E. These are the points about which we need moment. These are the points about which we need moment. So before you find the moment about all of these points, first of all, you have to resolve this force into its horizontal and vertical components. Resolve because it is inclined. You cannot keep any of the forces inclined in the given system. So since this particular force is inclined, you have to resolve this force into its horizontal and vertical components. So what would be the horizontal component? This would be the horizontal component. Horizontal component is 100 cos 30. 100 cos 30. We'll not consider it to be negative because we don't consider the direction. Usually, if the force moves horizontal to the left, we consider it as minus 100 cos 30. Here, in the concept of moments, we don't consider the direction. So, let it be 100 cos 30 and let the vertical component be 100 sine. Hope you know how to resolve. Now, instead of one single force of 100 Newton magnitude, we have two forces of 100 cos 30 and 100 sine 30. Magnitude of two forces. We have two forces of the respective magnitudes. Right? So both the forces will produce moment about all the points. Now let us consider point A. We need moment about A, B, C, D, and E. Let me consider moment about point A. So here, since both the forces act exactly on point A, moment produced by both the forces will be 0, or about point A, moment will be 0 because force acts exactly on the point. It is one of the conditions for the moment to be 0. Done. So this is the first point. We are done with the first point. Let us go through moment about B. We need a moment about B. First and foremost thing which you are supposed to check is whether the given forces, you have two forces here, whether the given forces produces clockwise or anti-clockwise movement. Let me consider this force of 100 magnitude 100 cos 30. Check whether this force produces clockwise or anti-clockwise moment about point B. Here line of action is horizontal, force moves horizontal to the left and point lies below the line of action. So this force will produce moment in this direction as far as point B is concerned. So this is again anti-clockwise. So it is minus 100 cos 30 into what's the perpendicular distance? Line of action is this and point B is this. So perpendicular distance will be 4. So this is the moment about point. We have to simplify this and write it down in terms of Newton meter. Done. This is the moment about point B. Again, this is done. We have considered only one of the forces, 100 cos 30. Why not 100 sin 30? Because when we draw the line of action of 100 sin 30, line of action passes through point B, is it not? Line of action passes through point B. So 100 sin 30 will not produce any moment about point B. It cannot produce because the line of action of 100 sin 30 passes through the point B about which we are calculating moment right now. So 100 sine 30 will not produce any moment about B. So this is the only force which produces moment about B, and moment about B is minus 100 cos 30 into 4. Into 4. You have to simplify this. Now, the third point, moment about C. Moment about C. Moment about C. This is the point. So we have to consider both the forces. We have to consider both the forces. Check whether this force of magnitude 100 cos 30 produces clockwise or anti-clockwise moment. It will be anti-clockwise. Minus 100 cos 30 into. What's the perpendicular distance? Line of action is this. This is the horizontal. Force is horizontal. Line of action is horizontal. And point lies below the line of action. Point lies below the line of action. So perpendicular distance will be 4. So we are done with this particular force. Here in this case, as far as point C is concerned, even the vertical force produces some moment, is it not? So check whether the vertical force produces clockwise or anti-clockwise moment about the point C. So it should be, see, the force is vertical, it moves vertically upwards, and the point about which we need moment lies in the right hand side. C is in the right hand side of the vertical line of action, is it not? So this force should produce moment in this direction. So it is clockwise. Plus 100 sine 30 into. What's the perpendicular distance? This is the line of action. Perpendicular distance from the line of action to point C, which is 6. Simplify this and find the overall moment. This is as far as point C is concerned. Let me consider the other point, which is point D. Point D is a moment about point D. Moment about point D. This is point D. So let us consider both the forces. Check whether 100 cos 30 produces any moment about the point D. It will not produce, because when we draw the line of action of point, this particular force, it passes through point D. So 100 cos 30 cannot produce any moment about point D, but 100 sin 30 will produce some moment about point. Check whether 100 sin 30 produces clockwise or anti-clockwise. It will be clockwise, because line of action is vertical, force moves vertically upwards, and the point about which we need moment lies in the right hand side of the line of action. So it will be clockwise. 100 sin 30 into 100 sin 30 into the perpendicular distance is 6. Simplify this and find. And finally, the last point, which is point E. So moment about point E. Again, check. This is point E. So both the forces will produce moment about point E, because this is the line of action of the horizontal force. This is the line of action of vertical force. Both the line of actions does not pass through point E, so both the forces will produce moment about point C. So let us check whether 100 cos 30 produces clockwise or anti-clockwise. It produces anti-clockwise moment, which is minus 100 cos 30 into. What's the perpendicular distance? This is the line of action. I have drawn the line of action. This is the line of action, and this is point E. So perpendicular distance from line of action to point E. This is the perpendicular distance. So it will be 2 meters into 2. And check whether this force, this vertical force, produces clockwise or anti-clockwise moment. It produces clockwise moment. Plus 100 sin 30 into 100 sin 30 into perpendicular distance from line of action to point E will be 6. So calculate this and simplify this and find the moment about the last point E as well. So if the force is inclined, make sure that you resolve that particular force into its horizontal and vertical components. This you are supposed to understand. Hope this problem is clear. Let us solve 2 or 3 more problems. Let us go to the next problem, which is there in the notes. I have sent the soft copy notes. Let us go through second problem number 2 in the soft copy notes, which I have sent it to you. So which is this: z-axis, y-axis, and Point A is given here. This is point O. This is point O. And you have a force of 75 Newton magnitude. 75 Newton magnitude. And the inclination of 75 Newton magnitude is 30 degrees. And this distance from A to x-axis is given as 3 meters, and again from A to O is given as 4. This is the problem. So this is the given question, and as per this particular problem, you have to find the moment produced by this force of 75 Newton magnitude about the point O. Moment about the point O. So we need moment about the point O. This is point O, produced by this force of 75 Newton magnitude. 75 Newton magnitude. So since this 75 Newton magnitude is inclined, this force is inclined, you have to resolve this force into its horizontal and vertical components, is it not? So if any of the forces in the given system is inclined, you have to resolve it into its horizontal and vertical components. So let me resolve this force into its horizontal and vertical components. This will be the horizontal component and this will be the vertical component. So horizontal component will be, again, it moves horizontally to the left. We don't consider direction here in the concept of moment. So it will be 75. Usually we consider it as minus 75, but it is 75 cos 30. And vertical component, again, it moves vertically downwards. Even though it moves vertically downwards, we don't consider it as negative in the concept of moments. Let me just write the magnitude here. It is 75 sine 30. So we have resolved this force into its horizontal and vertical components. So instead of 75, one force of magnitude 75 newtons, we have two forces. We have resolved the force into two. We need moment about point O. We need moment about point O, and both the forces will produce moment about point O. Both the forces will produce. Let us consider both the forces one by one. Let me consider the force of 75 Newton magnitude. Force of 75 Newton magnitude. Now, let me draw the line of action. This is the line of action as far as this particular force is concerned. Now, line of action is horizontal. Force moves horizontally to the left hand side, and point about which we need moment lies above the line of action. Lies above the line of action. Point O lies above the line of action. So this force should produce moment in which direction? In the clockwise direction. In clockwise direction. It is positive. Plus. What's the magnitude? It is 75 cos 30. 75 cos 30 into what's the perpendicular distance? This is the line of action, and perpendicular distance from the line of action to point O is 3 meters. This is the perpendicular distance. Line of action to point O. Line of action to point O is 3. Done. Let us consider the other force of 75, magnitude 75 sine 30. Force is vertical. Let me draw the line of action. This will be the line of action of the force. For line of action is vertical, force moves vertically downwards, and point about which we need moment lies the left hand side of the force. It's the left hand side of the force. So this force should produce moment in this direction. So it's again clockwise. Plus of this plus 75 sine 30 into what's the perpendicular distance? It is 4. It is 4. Calculate this and then get it in terms of Newton meter, either clockwise or anti-clockwise. So it's there in the notes. It's the second problem in the problem number 2 in the photocopy notes. Let us solve few more examples and let the other examples be given as assignment or homework. Let me solve the sixth problem. Problem number 6 in the photocopy notes, which I have already forwarded to you. Problem number 6 is in this way. You have something like this. So this particular point is A, and it's not given as A here. Let it be without any name. So let this point to be B. It's given as B here in the question. It's given as B. Only one of the points is being named here. So let this distance be 2 meters. Let the other distance be 2 meters. let this be 1 meter. Given this kilometer. You have a force of 25 kilonewton. 25 kilonewton. And the inclination of this particular force is 30 degrees. This is the given question. This is the given question, and here in the as per this particular problem, as far as this particular problem is concerned, you need a moment about point B. Moment about point B. Single step answer. It's moment about point B. In order to find the moment, this is point B for the reference. So this is point B. So in order to find the moment, here the given force is inclined again. Given force is inclined. So whenever you have an inclined force, you have to resolve it into its horizontal and vertical components. You have to resolve it into its horizontal and vertical components. So this is the horizontal component, and this is the vertical component. Horizontal component is 25 cos 30, and vertical component is 25 sine 30. 25 sine 30. So both the forces will produce moment about point B. So let me consider this force now, the horizontal force. Force moves horizontal to the right, and the point about which we need moment lies above the line of action. Above the line of action. So this force should produce moment in this direction. Is it clockwise or anti-clockwise? It is anti-clockwise. Minus 25 cos 30 into what's the perpendicular distance? It is 1 meters. This distance. It is 1 meter. Again, let us consider the vertical force now. Vertical force. Line of action is vertical. Force moves upwards, and point about which we need moment lies in the left hand side of the line of action. So moment produced should be in this direction. Should be in this direction. So it will be anti-clockwise again. Minus 25 sine 30 into the perpendicular distance. This is the line of action. This is point B. We need the perpendicular distance. We need the perpendicular distance. So it is 1 plus 2, which is 3. 1 is this, and this is 2. 2 plus 1, 3. Simplify this and solve. So these are the two problems, 2 or 3 problems. We went through 3 problems. You can solve the other problems which are similar to this. Please go through the notes and solve it. Thank you.